Okay, guys, so this is my best shot going over quick rendition, summarization of what DeWitt said in his YouTube video on endo and exothermic phase changes. The thing that I want to emphasize most is what the heck is going on with the molecules, and what's going on with energy and heat in each one of these. And this is the most simplified version we can get before we move on to endo and exothermic chemical changes. So if we start here, and we're going to be working with water because we all know water. We are all very familiar with it. We know how it all works. So if we start with a solid, water is a solid, and we think about the molecules and how they're ordered, we know that in a solid, the molecules are really tightly packed together. They have an attraction for one another. Even they're very tight, and even though they are not like moving around a lot, they're still vibrating. There's still motion in every single particle, in every single solid, whatever it happens to be. And we know that as long as there is heat in something, heat equals energy, energy equals motion. And so the only way we can get away from heat is to bring something down to 0 Kelvin. Now we know that scientists have not been able to bring anything to 0 Kelvin yet. They're close, but not quite yet. So as long as something is a solid, it still has energy, even though it's water and it takes the form of ice. What we need to do, though, in order to change a solid to a liquid is we need to add heat. Now, heat, scientific terms, the name we use is thermal. So heat, thermal, they're interchangeable. And adding thermal energy to this solid, what it will do is those solidly packed water molecules are tight together, and as they gain energy, they will begin to vibrate more and more and more, break apart from each other, break that attraction, and they will all together become a liquid. And as they are in this state here, it's gotten that way because we've added thermal energy, we've added heat, which gave it its motion, which gave it its movement, which made it break away from each other. So when we put heat into something, that's called an endothermic reaction. Endo equals within or in, and we've put heat in, which means it's endothermic. So now we're here sitting at the liquid, and the molecules are moving around each other. There's more freedom. It's less orderly. And we know this is true because if we pour a liquid into any kind of container, it'll take the shape of its container. So that shows that these molecules have freedom to move. Now, if we want to go from a liquid to a gas, what we must do is we must add more heat. So as we add more heat to this liquid, the molecules within the liquid gain more heat energy, and that energy will make these molecules move faster and faster and faster, and at some point they're going to break away and they're going to become a gas. Now you guys know how gas molecules move. They're nuts. Crazy amount of energy, bouncing off each other, bouncing off walls, bouncing off you, up to 1,600 kilometers per hour. There's a lot of energy in gas. And one way we know this is because steam is water vapor, and steam will burn you if you put your hand in it. So that shows that there's a lot of energy. They just don't hurt us, those molecules, gas molecules, when they hit us, because we're dealing with such a low amount of atoms at a time. So crazy erratic behavior of this gas. And then again, as we move from a liquid to a gas, we've placed heat or thermal energy into this liquid to change it to a gas form, which has more energy now. So that's an endothermic change. Now we can do the same thing in opposite direction. If we have a gas vapor, H2O, as a gas, and we remove heat. In science, remember, we don't make things colder. We either add heat or remove heat. And so this water vapor here, as we take away the heat out of that gas, what happens is that there's less energy. And so with less energy, there's less motion. It slows down and it becomes a more orderly system again of water molecules that are moving around each other as a liquid. Now, One easy way that we can see this happening is in the summertime. If you have a cold pop, you take it out of the fridge. You in the summertime you put it outside, and almost immediately water will start showing up on the outside of the can. Now, how that happens is that there is water vapor in the air. As soon as the water gas, the H2O gas, hits the can, it cools down this water vapor, and it cools down. The heat is removed from the water vapor as it hits the can, and it turns into a liquid, and we call that condensation. And that's an example of heat being removed out of a gas and becoming a liquid. Now, as we continue to go from a liquid to a solid, the same thing happens. If we extract heat from these liquid particles that are moving around, they have this much energy, we take heat out of it, these particles slow down more, and as you get cold, you cozy up and get really close to. And that's what happens with these particles as a solid. They come together and they start, shivering. They're cold. They're in the freezer and they're vibrating. They're very orderly, packed tightly together as a solid again. And this has happened by extracting the heat. And so it's an exothermic change again as we take heat out. Think about those terms as we go on to endo and exothermic chemical changes in the energy involved in each of the molecules of whatever compound element that we're talking about.